Welcome Algebra 1. This is 10-2, Simplifying Radicals. The essential question is, how will you simplify radicals? Let's begin. Some of this is repeat, but I'm going to do it anyway, so if you forgot this, take the notes, and if you remember it, skip till it doesn't say repeat anymore. Anyways, to simplify radicals, the right side is simplified in all these cases, so square root of 200 is equal to 10 times the square root of 2, and 96 is equal to 4 times the square root of 6, and 294 is equal to 7 times the square root of 6. How did I get those? I simplified those radicals. And this is one way to do this, and I call it the step method. You can do it whatever way you want, but the way I'm going to teach you and the way in this video is the step method. And you can do it your way. If you don't like this, that's fine with me. So first is to create a step. So if I didn't have a step right here, what this looks like if I want to simplify square root of 200 is I write 200 and then create a step, because the steps go down. Second, factor out the primes to the left and the remainder below. Keep going until you have a prime number. So that means it's 200. What prime number can I factor out? Well, 2, because it's even. So you go 200 divided by 2 is going to be 100. And then I create another step because 100 is not prime. And I keep going until I have a prime number. So that's still even, divide by 2. You're left with 50. Hey, that's still even, divide by 2. And you're going to get 25. And what is wrong with this? Oh yeah, and it's divide by 5, and then you're going to get 5, and that is a prime number. So we're done. Now I want to take all of my outside numbers, and I want to circle the pairs, and then square the alones. So what I mean is, here's a pair of 2's, I circle. Here's a pair of 5, I circle. This 2 does not have a friend, so I put a square around him. And the last step, pairs on the outside, alones inside. So in your radical sign, the outside is going to have the pair of 2's, so a 2, times a pair of 5's, so times 5 on the outside. Inside the radical is going to be this alone 2, so that 2 goes inside here. So what I have is 2 times 5 times square root of 2, which simplifies to 10 times square root of 2, which is the simplified form of square root of 200. Now, let's try that again with the other two examples. So 96, I can do my steps and divide by 2, and you're going to get 48, and I divide by 48, not by 7. 48 divided by 2 again, I get 24. I can divide that by 2 and get 12. I can divide that by 2 and get 6, and that by 2 and get a 3. And 3 is prime. So I have a pair of 2's, an alone 2, and an alone 3. That means I have 2 pair of 2's on the outside, so 2 times 2 on the outside. And inside I have a 2 times 3. 2 times 3, not 6. And then multiplying those, I get 2 times 2 is 4, square root of 6. That is a simplified form. For 294, same steps. So for 294, that's an even number, so I can factor out a 2, and I'm left with 147. And 147, that's not even, but there's a trick. If all these digits add up to something that can be divided by 3, I can divide the whole thing by 3. So 1 plus 4 plus 7 adds up to 12. So I can divide this by 3. And what I get is I'm going to get 49. And 49 is divisible by 7, and you're left with 7. So now my pairs are going to be a pair of 7's, an alone 3, and an alone 2. So a 7 on the outside, a 2 times 3 on the inside, which simplifies to 7 square root of 6. All right, let's get on to new stuff. So we know to simplify, let's simplify radicals with variables this time. So how do you find like the square root of a variable? Well, square root's like the second root. So all you have to do is half of the power. So half of the power, so half of these x's come outside. So you do a 4 divided by 2, and that's going to be 2. So the square root of 4 of x to the 4th is going to be x squared. It's just going to be half the number because we're square rooting it. So what about when we have an odd exponent here? Well, you can't just take half of that and write y to the 2.5. We don't want decimals in our exponents. So what you're going to have to do is split that y to the 5th into a y to the 4th times just a y to the 1. So that breaks up into, so breaking this up again, you have square root of y to the 4th times the square root of y. And square root of y to the 4th, we found out in that last slide, is y squared. So y squared times square root of y, and there's your answer. So you take out what you can and simplify what you can, but you're left with the rest inside. Now, here's a neat thing about this. Let's say I don't want to do it that way. I can still use the step method. I'm just going to move this over to the side. So watch this. I got my y to the 5th. I can factor out a y. I divide by y. I'm left with y to the 4th. Do a y again, and y to the 3rd. Y again. I'm left with y squared. Y again. Just left with y. Now, following the same pattern, I have a pair of y's, and then a lone y. So guess what? Two y's come to the outside, so y times y, and then a square root of y inside, which is going to simplify to y squared square root of y, which is the same answer. So you can follow the methods we did before. In fact, this is still going to work. Let's say I mix up numbers and variables. I can make it one big step. So I'm going to simplify the square root of 54 n to the 7th. So I'm going to write this as 54 n to the 7th. Make my step. Let's start with the numbers first. So I'll factor out a 2, and then that's from the numbers, so 54 divided by 2 is going to be 27 n to the 7th. I can divide by 3 and I get 9 n to the 7th. And I divide that by 3 and I get 3 n to the 7th. But I can't factor out more numbers, but I can factor out n's. I'm going to keep it purple. N, and so then I'm left 3 n to the 6th. Another n, 3 n to the 5th. Yeah, this is going to be big. Another n, 3 n to the 4th. N, 3 n 3. N, 3 n squared. N, 3n. And that 3n, you can't factor out anything more. You're going to leave it like that. No, actually, we should factor out another n. Another n, just left with 3. Just and no step there, because it's prime. Factoring out everything, so let's see what I have left. Okay, I am going to have a pair of 3's, and a pair of n's, and a pair of n's, and a pair of n's. And then I'm going to have an alone 2, and a lone n, and an alone 3. So, what I have on the outside is I'm going to have a 3 times 1, 2, 3 n's, n times n times n. And the inside I'm going to have a 2 times a 3 times an n. And to simplify all that, that becomes 3 n to the 3rd power times the square root of 2 times 3 is 6n. And there is my simplified form. Okay, let's say you want to do that a different way. You can simplify the number and variables separately, so you don't have to make one big step. So, and some of this you might be able to do in your head. So let's do the 54, and let's do the n to the 7th. And let's say I have to do the step method for 54. So I'm going to do the same thing. Divide that by 2, I get 27, 3, 9, 3, and 3. Fine. N to the 7th, maybe you know how to do that. I can split that square root of n to the 7th into the square root of n to the 6th times another square root of, that's hard to say, 6, times another square root of n. And square root of n to the 6th is n cubed, square root of n. And over here on the step method, we had a pair of 3's, a lone 3 and a lone 2. So it became 3 times the square root of 2 times 6. So 2 times 3 is 6. Combining these two, they have to be multiplied together. So what you get is 3 square root of 6 times n cubed square root of n. But let's rearrange things so the coefficients are together. So it'll be 3 times n cubed times the square root of 6 times the square root of n. Square root of n. And then combining all that, what you'll get is 3n cubed times the square root of 6n, which is the same answer we got in the last step. So any different way you want to do that, that's fine. Some of that stuff you could do without the steps in your head. Some of it you may need to write out. All right, multiplication property. So what this says is if you have the, and we kind of did this already, so I'm kind of going backwards. If you have the square root of two numbers being multiplied, I can separate that into 2 separate square roots. Or I can do the reverse of that. If I have 2 separate square roots, I can combine them. Hey, I just did this. This is probably out of order. Oh well. So combining these two, what you want to look is these coefficients and combine those separately and combine the square roots. Multiply the square roots together and multiply the coefficients. So it's just like if you were doing, well, I don't want to say that. Let's multiply the coefficients. 2 times 3. And I'm going to keep the square roots together. Square root of 7t times the square root of 14t. Squared. All right, so I'm going to combine those. 2 times 3 is 6, and well, I'll just combine it this way. 7 times 14 is going to be 7 times 4 is 28. 98. Yes. times t, that's t to the 1, t squared is t cubed. All right, but I can simplify that square root of 98t cubed. And 98 simplifies to 2, 49, 7, and 7. 98 combines to 7 square root of 2. And that t cubed simplifies to t times square root of t. And you have times there's another square root of 6. So it's going to be 6 times 7 times t. It's going to be 42t. And then square root of 2t on the inside. There's other ways you could have done that too. But we'll do more in class. Division property. So what this says is if you're dividing two square roots, if you have a square root divided, you have a square root and a fraction inside, you can split that up into a square root on the top divided by a square root on the bottom. So for example, if I did the square root of 36 over 49, I can split that up into square root of 36 over square root of 49, and then square root of 36 is 6, and square root of 49 is 7. So we're going to use that division property in a few examples. Simplifying this one, square root of 64 over 49 simplifies square root of 64 on top and square root of 49 on bottom. And square root of 64 is 8, and the bottom that's going to be 7. So 8/7 is your answer. For B here, I'm going to split this up as square root of 8x cubed on top and square root of 50x on bottom. All right, so square rooting the top. What that's going to turn into is if I simplify that, and it's an 8. 8 simplifies to, well, 8x cubed is going to simplify to 2 times square root of 2. And that x cubed is going to simplify to x times square root of x, because there's 3 of them. Over 50. Now 50 simplifies. I can do the work over here. So 2, 25, 5, and 5. And you got a pair of 5s and a lone 2. And so that's going to be a 5 square root of 2 times another square root of x. Now I got to see what cancels on the top and bottom. Since everything's being multiplied together, we can cancel things that match on the top and bottom. First thing that matches is the square root of 2's. Next thing is the square root of x's. So all I'm left with is 2x on top and 5 on bottom. So there's my simplified form. Now, sometimes you want to rationalize the denominator. What does that mean? For simplified forms, you shouldn't leave a radical on the denominator. So don't leave a square root on the bottom. The radicals are the square root signs. So what you want to do is multiply the fraction by something to change the radical to a number. And what you're going to multiply is multiply by denominator. The denominator. So it's the denominator on top and bottom, because you can multiply any fraction by 1. So if I multiply it by square root of 7 over square root of 7, this is still 1 because it's equivalent to 1. Same on top and bottom. But if I multiply it like that and multiply across, I get square root of 3 times square root of 7 is square root of 21 on the top. And then on bottom I get 7 times 7 square root of 49, which simplifies to just 7 on the bottom and square root of 21 on top. This is our simplified form. The rational is now, there's no radical sign on the denominator. It's only in the top, and that's okay. Let's try some examples. Pause the video. All right, to simplify this, got to multiply by square root of 5 over square root of 5, which will be square root of 5 is square root of 25 over square root of 10s, which is going to be 5 on the bottom and 10s on the top, just like that. Let's do one more. Pause the video. All right, there's a few different ways of doing this. So I'm going to break this. I'm going to do this a little differently here. So I know this square root of 9. That's the square root of 9 times square root of a cubed. And the square root of 9 is going to be 3. So that's 3 times, and square root of a cubed simplifies to a square root of a times the square root of 2a. And combining what I can here, I'm going to get 3a, and then combine these square roots. 3a square root of 2a squared. Well, 2a squared, that a squared simplifies to square root of 2 times an a, because that a squared comes out. So we got 3a times square root of 2 times a, and combines to 3a squared square root of 2. That's it.